Good day, I am Professor Sujoy Ghosh of IIT Kharagpur and I teach in the Computer Science and Engineering department. I will be taking this course on computer networks. So, we will be having about 40 lectures in this series. So, today we will start with an introductory lecture which is about the emergence of computer networks. It is a brief history and a little bit about the protocols and reference models, which is an abstract view of computer networks. Okay, the textbooks for the course will be these three: computer networking, a top down approach featuring internet, that is one by Kuros; data and computer communication by William Stallings; and computer networks by A.S. Tannenbaum. Okay. So, some of the material that we will be covering here verbally as well as in the slides will be from these books. Okay. Now, the first question is, what is a computer network? So, a computer network is a number of computers, also known as nodes, connected by some communication lines. So, we have these computers which are connected by some communication line. So, two computers connected to the network can communicate with each other through other nodes if they are not directly connected, which means that a computer does not have to be connected to all the other computers in the network in order to communicate with any of them. Okay. It may be an indirect communication via some other computer. Okay. And the other point is that these nodes, they are computers, but some of them are not computers. Some of them are sort of network devices. Now, there are various kinds of network devices like switches, routers, etc. So, they could also so they facilitate the communication and running of this entire network. So, they are also taken as nodes in the network. So, finally, we have some of the nodes, some nodes which may be either computers or there may be network devices like switches and routers, and there is a communication between them. This communication, of course, can be of various types. We will come to that presently. So, the computers can communicate with each other. Now, what do they communicate? They exchange information between different computers. Now, this information could be of any kind of information. They could be data used by a program, or they could be some program itself, or it could be any kind of information really. Okay. So, that is one of the basic and major use of computer network. Of course, there are other specialized uses of computer networks. For example, interconnected small computers can replace a large computer. For example, you have a very large computation to perform, and so for that either you need a very powerful and very large computer, which may be costly. The other option could be that you break up this work into very small pieces and assign them to the small computers. So, the small computers sort of do the computation on that small chunk of the problem, and then they communicate with each other to form the final solution. Then the other use of computer networks, which is coming into vogue very much these days, is that you can use this network as a communication tool. Okay, we know. Okay, the very basic, say for example, you send emails to I mean you can send emails to almost anybody these days, and that is really a very cheap and very fast mode of communication. Secondly, the computer network could also be used for direct communication, like say you could have communicate through voice over a computer network, you can communicate through video over a computer network. So, all these different communication is converging into this computer network, and as a matter of fact, nowadays when we talk about the network, we do not look upon it just as a computer network. As a matter of fact, it is the bedrock on which, say, all this computing, communication, all these are converging. And then of course, you have some applications which are necessarily of distributed nature, all right. For example, let us say railway reservation system. Now obviously, even if you had a large computer to handle all the railway reservations in the world in one place, but you would not want all the people to go to one place and sort of form a huge queue. So you want to distribute this functionality, that means for that of booking tickets all over the country, and that is what we do. So these are sort of examples of distributed systems. So this is a distributed reservation system. Similarly, there could be other kinds of distributed systems, there could be distributed databases and all kinds of applications. So that is the other application of networks. Now a quick look at the history of this computers first, and then we will sort of focus on computer networks. Well, in 1948 we have the first commercial computer installed. It was an UNIVAC, that was a big company once upon a time. And then in 1958 the first US communication satellite became operational. So you see, the network always has these two components. One is that you have to have these computers, and then you have to have these communication channels, and satellite communication is of course one of an important medium of communication. Then in 1964 we have an airline reservation system which uses some kind of packet switching network. It was proposed by the RAND Corporation, and in 1969 ARPANET, the first packet switching network, began its operation. This was actually a watershed event, as we will see. This had very far reaching impact on the way computer networks developed. Then in 1971 we have the first computer chip. Previous computers were made through very low level gates and all, but the first 4-bit small computer chip with 2300 transistors, they became available in 1971. In 1972 Ethernet specifications was formulated. Now this Ethernet is one protocol, so to say. So we will talk about protocols and different kinds of protocols, and Ethernet remains one of the most important network protocols that we use. So that was first formulated in 1972. In 1974 IBM introduced its own version of network in SNA. Then in 1975 Altair 8800, first commercial microcomputer that was sold as a kit. So we are actually looking at a very brief history of computers in general. So in 1975 we had the Paul Allen and Bill Gates getting together, which eventually formed Microsoft. We all know about Microsoft. 1976 Wozniak and Jobs built Apple I. So Apple also had a lot of contribution to make in to computers in various aspects, and Windows system that we see today almost everywhere, it was basically, it started from Apple computers. In 1979 we had the VCalc as the first commercial spreadsheet. So that is a very popular application of computers these days. In 1981 IBM introduced IBM PC with one floppy drive. Okay, later on they changed it with a drive and a hard drive also. And in 1983 TCP IP. So this TCP IP is another network protocol that we are using. Actually we use both Ethernet and TCP IP. So we have different protocols which are running on the network we require, and how these different protocols are arranged and how they are used, that I will cover today in the second part of the lecture. So, this TCP/IP is another important protocol that is still very much prevalent today, that became the official protocol of ARPANET. Remember the ARPANET we talked about, that is a network which was set up in USA under DRDO and which had a very far reaching impact on the way networks developed. In 1984, Apple introduced GUI with Apple Macintosh, and 1986 we see the first laptop PCs. 88, so IBM gives a multitasking OS for the PCs. 1989, Microsoft releases Windows, which is another multitasking system, that is the Microsoft version. 1989, NSF, that is the National Science Foundation of USA, it replaces ARPANET as Internet backbone. And then WWW was invented by CERN physicist Tim Berners-Lee in 1991. So, this advent of WWW, that means the World Wide Web, really made the network very, very popular. So, there was this kind of positive feedback going on. Okay, as it became more popular, more and more people jumped into it. As people showed their interest, so commercial companies also then became interested, because there would be a market for something in networks that they do. And when the commercial companies developed something, naturally it became more easier to use the network. They had more functionalities, so more people became interested. Okay, so that was the positive loop which made this I mean, actually then the growth of network in the past decade, that means in the 90s, let us say, has been absolutely phenomenal. Okay, and if the basic so called killer app, that is the killer application, the application which attracted so many people to networks, was this WWW, which was invented in 1991. In 1992, Mosaic released first GUI web browser, so that was a web browser. Then Netscape became the popular web browser. Microsoft, of course, had its own version of Microsoft Explorer, so that was another browser. And then it all built up into some kind of a frenzy, and in 2000 we had this .com, so called .com meltdown. That means, I mean, people became absolutely frenzied about the growth of computers, and of course such a frenzy cannot go on forever, so it has to come to a halt. So it did in 2000, but the development of networks and its utility and importance remains. So now let us go to a brief history more focused on the network itself. So that part, so we were in general talking about the computing scene in general. So in mid 1960s, USA Department of Defense wanted a command and control network that could survive a nuclear attack. Now if something had to survive a nuclear attack, then you have to distribute it. Okay, so that was one strong reason that we want a distributed system, and if you have a distributed system, these systems must be able to communicate. So that was the seed of this project. The subnet should consist of some Honeywell 12 kW intermediate message processor. So there are some kind of early network devices, you might say, which are connected by 64 kbps lines. These IMPs, or intermediate message processors, were connected to the various computers, and the IMPs themselves were connected by telephone lines from telephone company. Later the IMP software was changed to terminal interface processor, which allowed the connection of terminals. In 1970s, NSF set up a machine connected to the ARPANET, to which other universities could dial up and connect. Now this became very I mean, important in the sense that many people were interested in this. So NSF upgraded their system in various ways, and by mid 1980s NSF built a new backbone to connect its supercomputing centers to some regional networks. So this backbone was upgraded to 440 8 kbps and then to 1.5 Mbps fiber backbone. And once this fiber backbone was there, communication was really fast. So it allowed network connection to hundreds or thousands of universities, research labs, libraries, museums, etc. So as the growth continued, Now, commercial houses began to take notice and to join the decentralized model began to take hold. And as I just described earlier, that as the commercial people joined, so there was a lot of innovation by a lot of people. One of the major driving force in the computing networks in the past decades or even now maybe has been the role of so called startup companies. By startup companies, that means that some young engineers maybe or some young people, they had some very bright idea which they developed to a certain extent, and if when that was sort of proven, then some big company would possibly buy up their company or give them money to get access to this kind of technology. And a lot of people and there were so many success stories that a lot of people got interested in it, and when a lot of people think about a problem, naturally there is a lot of innovation. So that is how computer networks had an explosive growth in the whole of 90s, and even in this century, that is 21st century. The growth is going on, although the frenzy in the stock exchanges etc. about these .com companies, that sort of crashed in 2000, but the growth in the field of networks and its use in various walks of life, that is continuing. Okay, with this brief historical background, now let us come to the networks and some kind of structure or some kind of an abstract view of this computer network. All right. I have already mentioned that computer networks would be a number of nodes, and nodes could be computers or nodes could be network devices also, which are connected by some communication lines. Okay. Now, when I say that, of course, sometimes things are not so simple. Sometimes you do have a line between two nodes, let us say, so giving us the so called point to point communication. That means one node A is communicating directly to another node B, where A and B are connected by a direct line, let us say. Okay, it could be a physically some copper line or some fiber line, etc. So, but this point to point connection could be, so in the simplest case they are actually dedicated, but in the dedicated case also we have some different cases. For example, you could have simplex communication. By simplex communication we mean that communication can go in only one direction in that line. All right. It could be half duplex. By half duplex, that means that the communication could go both ways, either way, either from A to B or from B to A, but only in one direction at a time. And full duplex, of course, that A and B can communicate with each other simultaneously, that is parallelly at the same time. Okay. So, that means there is communication from A to B and from B to A at the same time. Okay. So, these are the different kinds of dedicated lines. Then, if the nodes are not, say, computers, some network devices, specifically if they are sort of multiplexers, then we could share a point to point medium. That means there is one line from A to B, but A is connected to a lot of other nodes, let us say A1, A2 to AN, and B is connected again to a lot of other nodes, say B1, B2 to Bn, and they could all, these AIs and BIs, they could all communicate through this one single line which is between A and B. So, this we will see later how such a thing can be done. So, this business of sharing a link over time or whatever, even parallelly, sometimes that is possible. So, sharing this link by multiple people, that is called multiplexing. So, these are the different kinds of point to point links, but point to point links are not the only things we have. For example, we could have a broadcast kind of link. For example, if you have a satellite communication, okay, a satellite sort of throws its signal all over the country or maybe all over the region. So that is something which is being broadcast to everything. So you cannot really put it down as a point to point link between something, but of course you could use that shared medium and a broadcast in some way to make temporary point to point links, or your application may be such that you want to broadcast something. Okay, for example, we broadcast TV signals. Similarly, there are things you might want to broadcast all over. So there could be so this broadcast medium again could be dedicated to some users, or it could be shared. That means it is shared between multiple users. So there the term that is used is multiple access, a medium to which different users are connected at different points, and it is a broadcast kind of medium. So in a distributed fashion they have some protocol of deciding how to share this, because if it is in the same place, you can the business of sharing becomes somewhat easier, so you can multiplex it. But if the nodes themselves are distributed over this broadcast medium, physically distributed, that is, so you will have to have some kind of protocol. So that is called multiple access. So you can have a shared broadcast medium also, that is also quite common. And then finally we have this something which is in between broadcasting and point to point, which is called multicasting. This means that, say we have a group, I have say some friends, and I want to send some things which not to one particular friend, but to my group of friends, but to no others. So multicasting is basically giving communicating to a specified group. Okay. So using such communication link, we have these computer networks, and the networks themselves are quite often popularly they are sort of divided into local area network, metropolitan area network, and wide area network. Local area network is just that, which means that it is local. That means it is sort of limited to maybe one building or maybe to a small group of buildings. So its size is small, that is one thing. There are some other things about local area network which makes the issues of local area network somewhat different from a larger network. So, and that is that a local area network would usually be privately owned. Now how does ownership come into picture? Ownership comes into picture because if you have a same owner for the entire network, then you can have the same policy, all right. So which is not the case if it is a very wide area network. We will come to that wide area network, that is the other case, where there may be the different parts of there are various nodes which are connected to this wide area network. The nodes may belong to very different people, and they may have very different ideas about what should be done and about all their policies. Okay. So that makes that wide area networking somewhat different from local area networking. And in between we have this metropolitan area network. Okay. Metropolitan area means say a network which is spread over a community or maybe even a city. So they are bigger sizes than local area networks, and there one of the issues which is very important is the access issues, which means that how do you connect. For example, you want to make an entire community networked. So how do you connect each one of them, because they are geographically more distributed than a local area network. Local area network, maybe you would like to sometimes we would use wireless, sometimes we would just simply draw wire, and the cost will not be very prohibitive. But in local area, how we connect the people, that becomes an issue. So that is the access issues. And we have talked about the wide area network. Wide area networks are costly. They are that means naturally when you are talking about communicating over maybe hundreds or thousands of kilometers, okay, the communication is costly. The cost has come down, okay, and that is another thing which has historically happened. As more and more people got interested in the network, technology developed. That is one side of the issue. The other side of the issue is that the volumes went up, which means that the number of people who used networks, so as the volumes went up, the cost went down. So, the technology improved in one direction. So, that was one input into bringing down the cost, and the other issue was that more and more people started using it. So, the volume to a particular company, let us say developing something in the network area, so that went up. So, they could make it make things cheaper, and as the whole thing becomes cheaper and cheaper, more and more people wanted to get to join the network, all right. But wide area network cost is still an issue, and of course, wide area network, as I said, that it may connect various local area networks. So, it is a network of networks or internetworking, or I mean as we know it very popularly these days, that is the internet. Okay. Now, let us look at abstract idea about the network in general. So, in the formal framework we have what are known as protocols. Okay. Now, why do we need protocols in networks? We need protocols in networks because network by its very nature, they may connect various different people, and as I said, various different people may have very different ideas about how things are to be done. Now, if people have very different ideas about how things are to be done, then but they have to agree on some common basis, otherwise they cannot communicate, and this common basis is the protocol. Okay. So, there are actually there are a number of protocols which are used in any network, and we will be getting into that. So, you and I may have very different ideas about how some particular thing may be done. So, I may be doing this in a certain way, you may be doing the same thing maybe in a completely different way, but if we want to communicate, we have to agree on some minimum protocol. So, that is the protocol. So, these protocols are the building blocks of this network, okay, architecture. So, each protocol object has two different interfaces. One is the service interface that defines operations on this protocol, and peer to peer interface which defines messages exchanged with peer, which means that, for example, any protocol. So, a protocol is, let us say, between peers, all right. So, if in this diagram, so these LIs, so there is these two boxes LIs, two LIs, they are the these two LIs, they are the different I mean peers, and they communicate with each other through this peer interface, that is the protocol. Now, this protocol is supposed to achieve something, is supposed to do something. For this it requires something maybe from some other so called layer. So, actually we have a layered architecture, and I am coming to that in the next slide. So, how this protocol is to be invoked, etc., for this we have a service interface, and between the peers we have a peer interface. So, this is a so we have all these different layers. So, we have this n plus 1th layer and nth layer and n minus 1th layer in general. Okay. So, actually these how they are to be layered, about that also there are some standards, and we will just look at two of them at least. So, let us say, for example, this networking business is broken up into I mean whatever the jobs you have to do for achieving for smooth functioning of computer network, we break them up into different functionalities, and these functionalities are in different layers. Now, this is all in one place, that means in one node. Similarly, another node which is connected to the network will have its own layers, and this at the same level, let us say n and n here, they are peers. Okay. So, there will be a protocol between this n and n, whereas there will be a service interface between the n plus 1th layer and nth layer. Similarly, there may be a service interface between the nth layer and n minus 1th layer, and so on. So, let us see what they are like. So, as I said, most networks are organized as a series of layers. The task of each layer is to give some service to the upper layer. So, that is the task of each layer, and any layer maintains a virtual connection with the corresponding layer in a peer. So, this virtual connection, any layer which maintains a virtual connection, this virtual connection is used for running the peer to peer protocol, whereas that this is the service interface, the task of each layer. So, each layer performs certain tasks, certain subtasks of this whole networking business, alright. So, each layer performs some task. So, this task is a service to the upper layer. Similarly, for performing this task, it may break it up into some subtask, and some subtask may be delegated to a lower layer. So, this layer would have its own service interface to the lower layer, whereas its own task, which whatever, I mean, assuming that the subtask is done by the lower layer, its own task is performed at the peer to peer level using the corresponding protocol. So, there is peer to peer protocol running between any two corresponding and communicating layers. The interface between the layers in the same node is well defined. Well, another point is that for this peer to peer protocol, mostly they go through what I have just now called a virtual connection. That means, so what is a virtual connection? Virtual connection means that well, physical connection we understand. Let us say two computers are connected by a wire. Okay. Now, as I mentioned earlier, two computers may not, I mean, it is not necessary that the two computers need to be directly connected in order to communicate. It may be an indirect connection also. That means it is going through from one computer to another, then it is hopping from node to node, and then it reaches finally its destination. So, there is no direct physical communication, although let us say when you are surfing the internet, let us say, which is a very common experience these days. So, you have connected to some computer which may be in the opposite part of the globe. So, to you it appears that you are sort of directly connected to that computer. Okay. So, whenever you are clicking something over here, something happens, which something happens means, of course, something happens. So, that your clicking of the mouse somehow that gets communicated to that remote server, remote web server, and it may be the page changes or something, alright. So, there seems to be a direct communication, but this communication is only virtual. The physical communication is only at the lowest layer, where physically something may be communicated by connected by a piece of wire, or it may be connected by fiber optic links, or it may be connected by maybe satellite links, whatever it is. So, that is the physical connection. So, that is why these for running all these protocols, these peers need to communicate, and this communicate is through a virtual connection. Okay. Now, the implementation of each layer in each node is transparent to other nodes. Okay. Now, actually this is the main point of having this layered architecture, that the implementation of each layer in each node is transparent to the other nodes. As I said that I may want to do this one particular subtask in some particular way. I means, let us say, some company X, and then some company Y wants to do the same thing, maybe in a different way. Now, you need not stop any of them. Okay. So long as they agree on the protocol, so long as they agree on the service layers, that what is the service interface between the different layers, because upper layer service may be given by some product of some company, whereas the lower layer of the lower layer is maybe developed by some other company. Now, once again, if they can decide on the interface between these two layers, it is all right. Now, then they are very free to do it in their own way. The same thing applies to the peers. For example, say two nodes, say two particular layers in two particular nodes may be peers, and let us say these nodes are computers themselves, all right. Now, one may be an IBM machine, another may be a Sun machine or something, all right, and they will have different operating system, they will have different processors, etc. But so far as the peer to peer protocol is concerned, they agree. Okay. So, these are the messages I will send, and then if I am expecting this kind of answer, and he said, okay, these are the kinds of messages that I will accept, and this kind of answer will be given, etc., etc. So, that is how a protocol goes. So long as they agree on this protocol, these two companies are free to develop their product in their own way, and when you allow that, naturally people can innovate, people can put in different things, so long as you are conforming to the standards of the protocol and the interfaces, etc. You can develop your own thing in your own way, and that is very good for the development of the program of this entire network. And the other point is that this is one way of abstracting out all these unnecessary details from the, for example, any of these networking say networked operating system in a computer or a networking device. Okay, they may be very, very complex indeed. Okay, and some of the complexity is special to the implementer. Okay, one implementer has decided to implement something in some particular way, and that will have a whole lot of details. Now, we are not really interested in that one, we want to abstract out of that. So, we concentrate on these protocols and the interfaces and the functionalities. So, that gives us a fairly general picture about the entire networking, how networking is done. And then if you are if you go into business of developing some of these modules yourself, then you have to go into some more nuts and bolts about how this service can be given. Now, the protocols between peer layers can be changed if the peers all agree. Naturally, if you are changing the protocol, all the peers have to agree, otherwise the communication will break down. However, it need not be referred to other layers. So, that is another good thing about layering. That means, when I am changing something in this layer, so long as I am not changing anything in the interface between the upper layer and this my layer, or between myself and the lower layer, so long as I am not changing anything in the interface, internally whatever change I make will not matter. So, that is the good point of this layering. And the service definitions tells what the layer does and nothing else. Okay. So, that means nothing else means nothing about the specifics of implementation, which may vary from one vendor to another vendor. The interface tells the process above it how to access it, it specifies what the parameters are and what results can be expected. So, we have two okay, I mentioned here three models. So, three layered models. The most famous is the OSI reference model, which we will look into some of the details, and then TCP/IP reference model, which is most widely used actually. All right. So, OSI reference model, some part of it is somewhat theoretical, because many people do not really do that, and they do not consider that part to be very important. But TCP/IP reference model is something which is almost ubiquitous. And for ATM, so the ATM is one networking technology, which is rather complete technology. I mentioned here this here just as an example. So, that is another kind of reference model. So, there are all kinds of different reference models. Sometimes these models, so these models are basically a description of the different layers that are there, and then naturally if you talk about the layer, so what that layer is supposed to do, that is what you say, and then how it is to be interfaced with the layer above and the layer below. So, since this is just a number of layers one on top of the other, they are also referred to as stacks sometimes. So, we call about the TCP/IP stack and the OSI stack and so on, ATM stack. So, other protocol stacks exist and new ones are possible. However, to the extent to which a particular model is universally accepted is the key to its success. As I said, that a lot of thought went into OSI reference model, but in practice TCP/IP became much more prevalent. Okay. So, let us see the OSI reference model. This has 7 layers, okay, and these layers are application layer, the presentation layer, the session layer, the network layer, the data link layer, and the physical layer, which means that in order that people can communicate over this network in a very seamless manner, all the jobs that are involved, that have been broken down into 7 parts, and they are the different 7 layers. So, application layer is something, and then presentation, session, network, data link, and physical layer. So, each layer has some kind of functionality, and all these functionalities together gives you the network overall functionality in the network. So, just a little bit more about peer level communication. Messages sent from one application to another application on different hosts. So, it travels down the layers on the sending machine, and each layer adds a header to be used by its corresponding peer level, and the bottom layer, which is the physical layer, sends the message to the receiving machine. So, this is the general scheme. The point is that suppose we start something at the very top, let us say in the case of OSI we call it the application layer. Okay. So, some communication has been initiated at the application layer, all right. Now, this application layer, mind you, is really, it has its peer, let us say in the destination machine. So, in the destination machine also some application layer program is running. For example, let us say you are doing a telnet kind of thing, that means you are sort of logging on to another machine. So, you are doing a telnet to another machine. So, you will start your telnet program, which will be a telnet client program, and the destination machine will have now the who will sort of respond to a telnet client, only a telnet server who can respond to a telnet client. So, this telnet server is on that remote machine. So, these are the two modules, both of which are in the application layer. Now, how telnet is an example of a protocol. This is an application layer protocol, and what this protocol does, how the telnet client will request, how the telnet server will respond, etc. These are the internals of this particular protocol, namely the telnet protocol. Now, so far as the telnet client or any of these application program is concerned, when it tries to communicate to another application program in another machine, it just knows about this protocol and how things are to be done at that layer. But how is this communication to go from this machine to another machine? For this, if you put the whole thing in the same program, then that becomes very complicated. That was the idea of layering. That means, so give him a sort of virtual connection. So, he will sort of for communicating to the target machine, he will have some data to sort of send. So, that we will add up to maybe other kinds of data, and then hand it over to the lower layer in the same node. Okay. Now, the lower layer similarly may be running a protocol with the corresponding layer in the remote machine. So, for that protocol it needs to do some communication. So, for that communication, whatever message is to be sent here, that gets added to the original data which was sent by the application layer. So, this way, as the message to be sent moves down the stack from the originating machine, at each layer is running its own protocol with its peer. So, it has some message to sort of add or give to his peer. So, they will keep on adding it to this. So, this becomes fatter and fatter as it goes down. Now, as it goes down to the physical layer, there it can now communicate to the remote machine, and in the remote machine this will now again move up the stack, and at each layer that particular the program or whatever that module in that layer, he will take out the message which has been sent by its peer in the source. So, that is how communication will go on for all these protocols. So, sending a message, so received on the receiving side, and it is passed up through each layer, and each layer reads the corresponding header. That means, the corresponding header which has been sent by by its own peer on the from the source machine. All right. So, this is an example. Let us say we have two machines, and one machine is a DOS machine. That means, it is some DOS is of course an old operating system which used to run on PCs, and which was there on the Microsoft DOS and the PC DOS, etc. IBM DOS was there, and Macintosh was a different company, as I mentioned. So, it is so these two can still communicate. That means, they are two very different machines, but this original data which was there, which sort of originated from the application layer. Now, there is a presentation layer. Now, this presentation layer will add its own presentation header to this original data. Now, this whole thing becomes sort of data for the next layer, namely the session layer. So, session layer will add its own header. So, as I said that the original data becomes fatter and fatter and fatter till it comes to the physical layer. Now, at the physical layer, data is actually sent, let us say in one hop, to the destination machine. Now, here as this whole fat packet travels up, each layer will strip off its corresponding header, which is coming from its peer in the source. So, that is how they each of the peers can communicate, and each of them has a virtual connection with the destination machine, although the actual connection is the physical connection. Okay. So, these are the 7 protocol layers. Now, we are going bottom up, and I will just tell you in brief. Later on I will just go down to how they are sort of some more details about each of these layers. So, first is the physical link, which is how to transmit the bits, and then we have the data link layer, that means how to transmit frames. Now, what is the difference between transmitting bits and transmitting frames? We will see to that, but a data link basically is a direct connection, that means how two computers which are directly or two nodes which are directly connected to each other, how they will communicate, that is a matter of data link layer. Now, as mentioned earlier, computers need not be directly connected to each other in order to communicate. They have to be connected to the network somehow or other. So, if there are say two machines A and B, or two nodes A and B which want to communicate, and there is no direct link between A and B, so it may go via C, D, E and then B. All right. Now, how do you know that you have to go through C, D, E and then you will actually reach B? So, somebody has to keep track of the route, how to route the packets over the entire network. So, that is the job of the network layer. Then there is a transport layer, that means how to send packets to the application. Now, we have been talking about packets. A packet is a sort of some data which is sort of has been segregated and put into a sort of packaged together. So, that is a packet. But the original application layer need not have any concept of any packet. So, somebody has to packetize all this data, and there are maybe other functions in the transport layer. So, that is they make packets out of the data given by the upper layer. So, that is a transport layer. There is session layer, which manages the virtual connection between of the application layer. It manages the virtual connection and some properties of this connection. We will talk about it. The presentation layer, that means how do you encode and decode messages, that means two different machines may have two different ways of encoding things. Okay. So, there is that is the job of the presentation layer, as well as the security comes here, and application. So, whatever the actual job the user is interested in, the human user, that is, so that comes in the application layer. Okay. So, the application layer contains a variety of protocols. So, it depends on what you are trying to do. So, the various users may want to do various things. Examples are FTP, Telnet, SMTP, HTTP, etc. So, these are the names of some protocols. Okay. By the FTP protocol, what you can do is that you can download files from another machine. By HTTP, you can look at web pages, surf, etc. There is a protocol called SMTP, which you use for sending mails. Okay. Now, you may not have come across these protocols directly, but the point is that whenever, let us say, you are sending a mail from, let us say, an Unix machine or something, you are using the SMTP protocol, whether or not you know it. So, SMTP protocol has been built into that. Similarly, when you are telnetting, that means the telnet server and the telnet client, etc., they will be there in your machine as a part of the OS maybe. So, the application layer usually requires reliable and cheap connection to its peer. That is what the application layer what it is concerned about, that it must be connected reliably and cheaply to its peer. So, examples of peers we have so given some nodes giving service, etc. Now, application layer hands this whatever it has to send to the presentation layer, which handles, as I said, the format of the data, protocol conversion, data translation, whether it is ASCII or maybe some other EBIGDIC or something, data compression, data encryption, these are handled in the presentation layer. In the session layer, it allows applications on different computers to share a connection. Now, what do I mean by connection? The point is that later on, just as I go to the next layer, you will see that I will packetize this data, but then so far as the user is concerned, he wants a continuous connection. So, this connection is handled in the session layer. So, it can provide checkpoints. That means, if there is some disruption, you may come back to it and sort of get the original original state back, and then you can retransmit if there is some this thing, dialog control of who can transmit, etc. The transport layer, the basic function of the transport layer is to accept data from the layer above, split it into smaller units if necessary. Now, why we need to split that, we will come to that later on. Pass these, so these are the packets, so to say, pass these to the network layer and ensure that the pieces all arrive correctly and in the right order at the other end. For example, you have chopped them into pieces, now they may become out of order. So, that is a business of the transport layer. This should also be done in a cheap and efficient manner, etc. The same thing applies. So, the type there may be different types of transport services. So, there may be multiple protocols here. One could be error free point to point channels, or it could be a very cheap kind of channel, or if it were broadcasting of messages to multiple destinations. So, these are the different types of transport services which are possible. The network layer, as I said, it decides on what route to take locally, so that the intended message ultimately reaches the destination. It controls broadcasting by essentially segregating the different networks, etc. It handles technological mismatches. So, we will get into the details of this later on. It does congestion control, it handles billing information, etc. And the data link layer make the physical layer appear like a channel that is free of transmission errors. Actually, in the physical layer there may be errors, but the data link layer handles this error correction, etc. at the very lowest level. And finally, at the lowest level we have the physical layer, where data is actually transmitted as raw bits, etc. The other layer is TCP/IP reference model, whereas the session and the presentation layer are not there. So, we have the application layer, transport layer, network layer, and maybe something like the data link or the physical layer. So, the rough correspondence is something like this. We have the TCP/IP model, where you have just these few, and you have the OSI reference model with so many. So, more or less they match, the essential functions match. And there are other kinds of protocols which are also used, but the TCP/IP and the OSI, these are the most common. In the next class, we will be discussing the different structures of networks. So, today we just had an abstract view of networks. In the next class, we will handle the different structures. Good day. So, in this lecture we will discuss the network topology. Okay. Now, what do we mean by network topology? Okay. So, just let's just have a quick recap of what we had learned last time. Basically, a computer network would be a number of nodes which are connected by some communication links. All right. So, so there is some kind of what we usually call a graph. Okay. So, this graph has certain structure. So, we talk about the structure. Now, this structure has an implication about how we will go about communicating. As I said, that it is in general not feasible to have one-to-one communication between each pair of nodes. Okay, that is not possible at all. So, what kind of structure, that means what there is nodes connected in which manner, that is the subject matter of discussion today. Okay. So, a network may be represented as a graph, as I said, nodes representing computers or network devices like switches, routers, etc., and the links represent communication links. Modes of communication may be broadcast or point to point. We have discussed this. Okay. now now there are various first let us talk about the so called LAN topologies. By LAN, you remember, is the local area network, and local area network topologies are well, three are very common: star, ring and a bus. Okay. So we will just look at all of them. So first of all, we first take up this bus topology. And why do we take up a bus topology? So this is a very simple kind of network. Okay. So this is based on a shared broadcast link. So this so we still want to do point to point communication. That means there may be so many nodes A, B, C, D, etc., which are connected to the network, and A wants to communicate to B. Okay, so C, D, E are connected, that is all right, but A specifically wants to communicate to B. So each pair of communicating nodes use the link for a short time. So A uses the link for a short time to send its message to B. Then after that is over, then maybe C might send something to D or something like that. So other nodes ignore the communication. So since this is a shared broadcast link, all the links all the nodes get the communication. So that is not private in that sense. So all the nodes get that communication, but they usually will ignore this communication, whereas a B will sort of copy this for its own purpose. Now there has to be a distributed protocol to decide who gets to use the link. Okay, there has to be some protocol, otherwise if A wants to communicate with B and B wants to say C wants to communicate with D, their communications will go and collide in the shared broadcast medium. So the communication of both the parties, that means both the pairs of nodes, they will get garbled. So that and sometimes actually that will happen, that the things will get garbled, but that is not what we want to.